In this video, we want to work on some important identities. First, we want to solve this problem, and then related ideas. We have this part, hints. You can use them, similar problems. You can check my website here. We have 3 similar problems. After solving this problem, we'll be solving this problem of AMC. Again, we have related ideas, hint. And you can do this problem, these 2 problems as homework. This problem again from AMC 10B and the other problem from BMO round 1. Problem 3, British Mathematical Olympiad 2018. I can say the most 2 prestigious national Olympiad exams are BMO and AMC related to USAMO for America and UK. And many ideas are similar, so if you want to work on other national Olympiad exam, except, for example, USAMO or AME, you can work on BMO. Okay, problem 6, daily problem 6. We have this. It says x is a real number. Find x 2 to the x plus 3 to the x minus 4 to the x plus 6 to the x minus 9 to the x is 1. Related ideas, change of variables, important identities, and hint is what? Consider a is 2 to the x, b is 3 to the y, sum of 3 squares is equal to 0. Okay, so we can say here, as I said in the hint section, a is 2 to the x, b is 3 to the x, so let's write. First one is a, next one is b. 4 is what? 4 to the x. I want to use a. Is 2 squared to the x. And by power rule, we can say a to the m to the n is equal to a to the n to the m is equal to a to the mn. So we can switch like here, 2nx, it will be 2 to the x squared. So it will be what? It will be a squared minus a squared. 6 to the x is what? You can write ab to the n is equal to a to the n times b to the n. So we can say 6 to the x is equal to 2 times 3 to the x. So it's 2 to the x times 3 to the x. It is AB. So this one is equal to AB. 9 to the x, like 4 to the x, we can write it as negative b squared is equal to 1. In next step, we can take all things to right hand side. So it will be a squared plus b squared minus ab minus a minus b plus 1. Okay, now in next step, I multiply both sides by 2. It will be 2a squared plus 2b squared minus 2ab minus 2a minus 2b plus 2. Then I rearrange this, a squared plus b squared minus 2ab plus a squared minus 2a plus 1 and b squared minus 2b plus 1. Now I want to use one of our identities, this one, binomial theorem. For n, I told you x plus y to the n. I want to use a special case here. Special case when it is 2 and instead of plus y, you replace with negative y. X minus y is x squared minus 2xy plus y squared. So 0. The first one is something squared. Can you say it is what by applying this? It is a minus b. You can pause the video and try to find first on your own. A squared minus 2a plus 1. If we use this, it will be a minus 1 whole squared. And next one, this one, it will be b minus 1 whole squared. Now, we want to use this idea. Sum of 3 squares equal to 0. They are real numbers. X is real numbers, so a and b, because they are 2 to the x, 3 to the x, they are real numbers. So all of them are at least 0. So we can say some of them will be at least 0 because some of them equal to 0. Each term should be equal to 0. Okay, the only possible case. So a minus b should be 0. A minus 1 should be 0. B minus 1 should be 0. Is this idea, I saw this in many problems, in awesome math, in many Olympiad exams. So a equals b from here. A is 1, b is 1. So a is b is 1. So A was what? 2 to the x. B was what? 3 to the x. So from here x is 0. Also from here we can conclude x is 0. So our only answer is x equals 0. Okay, now let's solve next problem, similar problems. 2023 AMC 10A problem 23. And again, here you can use related ideas, this hint, you can use hint, and also similar problems. You can use all these topics to improve your problem solving. Let's read the problem together. If the positive integer c has positive integer divisors a and b with c equals ab, then a and b are said to be complementary divisors of c. Suppose that n is a positive integer that has one complementary pair of divisors that differ by 20. So we can write n as a times a plus 20. And because it says a and b should be positive integer divisors, so a is positive integer. Also, another pair of complementary divisors that differ by 23. So we can write it as b times b plus 23. What is the sum of the digits of n? So we should find n, then find sum of the digits of n. Let me tell you something. We have exactly similar problem in BMO1. Exactly same problem. But that problem is for which year? 2018. So if you solve this problem before this AMC, the ideas are exactly same. So that's the reason I say try also problems of BMO. Okay, let's try this problem. For this one, we want to use what identity? Again, special case of binomial theorem. X plus y squared is equal to x squared plus 2xy plus y squared. So here we can say what? I want to write first one as something squared. It is what? Let me write a squared plus 20a is equal to b squared plus 23b. So I write first one as what? A plus 10 squared. Then because of this, I have a squared plus 2 times a times 10, this one and this one, but I have plus 100. Here we don't have plus 100, so I subtract 100. Now for this one, if I want to create b squared and 23b, it's b plus what squared? 23 over 2 minus what? Minus this squared. It will be 529 over 4. In next step, when we are working with integers, we don't like denominators. So to get rid of denominators, we should multiply both sides by what? By 4. So when you want to apply 4 inside square, you should multiply by 2. So 2a plus 20 whole squared, 100 times 4 minus 400. Again, 4 inside the square, we should multiply by 2. It will be 2b plus 23 whole squared minus 4 times this minus 529. Okay. In next step, I take 529, this to left hand side, this one to right hand side. So 529 minus 400 is 129 is equal to 2b plus 23 squared minus 2a plus 20 squared. I want to use a famous identity. X squared minus y squared is x minus y times x plus y. And we have for general n a formula. The formula is what? The formula is exactly this one. For n2, it will be a minus b times a plus b. But for n3 and 4, for all of them, we have this identity. I told you general form of many identities. Here, you can check these 8 identities. In my next videos, I will check the rest. Okay, so here, if I apply this minus this, it will be 2b minus 2a. 23 minus 20 will be plus 3. And if I add these two terms, it will be 2b plus 2a plus 23 plus 20, 43. it is equal to 1 to 9. Because I factorized 1 to 9, because this part is equal to 1 to 9, so I should prime factorize 1 to 9. It's what? 3 times 43. Okay, 43 is prime. Now, if I want to consider cases, I know this one is positive. This one is also positive because A and B are positive integers because of the definition of problem. So this part is positive, this part positive. We can conclude this part also has to be positive. And obviously, because A is positive, so this part is greater than this part because also we have 43, 3. So one case is 43, 3. We have one more case to check. It is what it is. 1, 2, 9, and 1. So we should consider these two cases. For first case, if I write 2b minus 2a plus 3 is equal to 3, 2b plus 2a plus 43 is equal to 3. So if I subtract 2b, 2b will be cancelled. Second one minus first one. 2a minus 2a, 4a. And, second one is 43. 43. 43 minus 3 is plus 40. And 43 minus 3 is again 40. So we can conclude A is 0, contradiction, because the problem says A is positive integer. Now let's check second case. 2b minus 2a plus 3 is 1. 2b plus 2a plus 43 is 129. Now if I subtract second one minus first one, then 4a plus 40 is equal to 129 minus 1, 128. So 4a is equal to 128 minus 40, 88. So A is what? A is 22. So we want to find N. N is A times A plus 20. N is A times A plus 20. A is what? A is 22. Times what? 22 plus 20? 42. And if we write, it will be what? 22 times 42. It will be 2 times 2, 4. 2 times 4, 8. 2 times 2, 4. And 8 again. 4. 8 plus 4, 12. And 9. So N is a 924. Sum of the digits, answer is 9 plus 2 plus 4. 9 plus 2 is 11 plus 4, 15. So the answer is 15. Which choice? Choice C. As homework, try to solve these two problems, 2023 AMC 10B problem 14 and this problem of BMO. If you wanted to improve your problem solving, you can check my website and you can send a message to my WhatsApp number in my website or in the description. Thanks for watching this video. Have a good day. Bye.